Section 3 is called the fundamental theorem of variation, and what we're going to look at today is kind of the relationship between one variable and how it affects another. So if I change one, what happens to the other one? Okay, so we'll kind of think about pizza because it kind of gives us something we can relate to. So we'll first look at the area. Well, area is pi r squared. So if I have a radius of 1, that gives me an area of 1 pi. If I have a radius of 2, 2 squared is 4, that gives me an area of 4 pi. 3 would be 9 pi, 4 would be 16 pi, 5 would be 25 pi, and 6 would be 36 pi. We can also take a look at a volume, which has a formula of s to the third. So if I had a radius of 1, that'd be 1 to the third is 1, 2 to the third is 8, 3 to the third is 27, and we get 64, 125, and 216. So we can see as we change the radius, okay, it definitely changes the area, gets bigger, and the volume gets much, much bigger. Okay, so let's kind of look and see what more specifically is happening. So if we kind of look at an example where the radius doubles, so that could be like going from a radius of 2 to a radius of 4, what happens to the area? Well, we went from 4 pi to 16 pi, which means I multiplied that by 4. Okay, and the volume went from 8 to 64. So my volume was multiplied by 8. Now this is going to kind of be a formula, but if we kind of think about it, 4 and 8 are related in the fact that 4 is 2 squared and 8 is 2 to the third. While doubling is multiplying something by 2, so that's where we get our base. And the squared and the third power here come from the square and the third power in our equations. Okay, so it should make sense if I double the radius, because this is a radius being squared, I'm going to multiply the area by 4. If my volume was doubled, I'd have 2 to the third, so my volume would be being multiplied by 8. So let's kind of see if that holds true for an example when the radius triples. So maybe we'll look at 2 and 6 now. So now I go from 4 pi to 36 pi. So that's being multiplied by 9. And then my volume is going from 8 to 216. So that's being multiplied by 27. Well, triple would be a factor of 3. And now I have 3 squared, which is 9, and 27 is 3 to the third. So I still have that second and third power coming from over here in my equation. Okay, so what we have is a very specific theorem that states y varies directly as x to the n and x is multiplied by c. Then we're going to multiply our answer by c to the n. Okay, and that's kind of what we just found, like 2 to the second or 2 to the third. And we're going to be multiplying, okay, because it's a direct relationship and both variables in a direct relationship go up. So we are going to kind of give ourselves, over on the left side, you've got some notes. C is going to stand for your change. So if we're doubling something, tripling something, N is going to stand for the exponent. Then we're going to say, well, are we multiplying or dividing? And then we're going to say by c to the n. Okay, so that's the formula. So let's answer some questions. The first one says, assume y equals 8 times x to the third. What happens if x is multiplied by 2? Okay, so we're going to find out two things. We're going to say I need a c and I need an n. Okay, so c is the change. Well, I'm being multiplied by 2, so my change is 2. N, we said, is our exponent, so from my equation, n is 3. And because this is a direct relationship, I'm going to say my answer is multiplied by c to the n, which is 2 to the third. So multiplied by 8 is my answer. Okay, so if I change this equation up here, if I multiply that x by 2, my y value will be multiplied by 8. What if I multiply it by 4? Well, now my c changes to 4, and my n is still my exponent from my equation, which is still a 3. It's still a direct, so I'm still going to say multiplied by 4 to the third, which is 64. Now I have c is multiplied by 1/3, so I'm going to say my change is 1/3. My n is still 4. It's still a direct one, so my answer is going to be multiplied by 1/3 to the 4th power, which happens to be 1/64. Okay, actually that's not 64, that's 81. Okay, so that's an example of the direct. Now inverse is going to be the same, only now is going to be divided. Okay, so it is now divided by c to the n. So c and n stay the same, but now inverse, your word is going to be divided by. So now we can assume that y equals 3 divided by x squared. What happens when x is multiplied by 3? So my c is 3, and my n is my exponent. In this case, it's a 2. Now this is an inverse relationship because of the division. So we're going to say our answer is divided by c to the n. And our c to the n is 3 squared. So it's divided by 9. Okay, what if x is multiplied by 5? So now my c is 5. My n is still 2. So I'm going to say divided by 5 squared, which is 25. Example C says, what if I multiply by half? Okay, so C is a half, N is still 2. I'm still dealing with an inverse relationship, so I say divided by 1/2 squared, so that'd be by 1/4. Okay, so the only tricky thing here really is making sure you do c to the power of the n and not flipping those numbers. Okay, now please do notice that we haven't touched this coefficient in our equation at all. Okay, the 3 is there no matter what we do to the x, so I am not going to take that into account at all because it is there no matter what. So please, please always ignore, okay, the coefficient in your equation. You're never going to use it. Okay, let's try a few more examples. Example A says y varies inversely with the 5th power of x. Okay, so maybe I'll just write an equation so I can have a visual. Y varies inversely, so that means divided by, and then the 5th power of x. That's my equation. So my question is, it's being divided by 2. So how is y changed if x is divided by 2? So my c is my change. Well, I'm dividing that by 2. N is my exponent in my equation, so that's 5. So c to the n is 2 to the 5th, which is 32. Now, the only thing tricky about this one is this is an inverse relationship over here, which means normally we would say divided. But this divided here usually says multiplied, which flips our answer to be multiplied by 32. Okay, so let me say that again. Usually this word in the equation says, what if we multiply something? We double it, okay? Which means this would be, because it's inverse, this means divided by. But this divided flips it back to multiplication. Okay, so it's kind of a double negative, so that flips it back to a multiplication. So let's look at B. Suppose h varies directly with the square of g. So maybe I'll write that out again. Kg squared. And g is being multiplied by 1/4. Okay, so my c is always my change, so I'm being multiplied by 1/4. My n is still my exponent, so that's 2. I need to find c to the n like the formula says. So 1/4 squared is 1/16. Okay, so I have a direct relationship. Direct means my word is going to be multiplied. I'm still multiplied over here, so my answer will be multiplied by 1/16. Okay. Let's try example C. R is inversely proportional to the 4th power of S. So R is K over S to the 4th. Okay, again, you don't have to write that down. That's just kind of nice for me to see because now I see inverse and I see division right here, which is a good thing. And it's being divided by 1/3. So I know my C is a third. My N is my exponent, which is 4. I still find C to the N, which is a third to the 4th, which is 1/81. Now the real question is, normally my answer is divided, but this guy over here is changing it up, so that's another division. So that should flip that back to a multiply by 1/81. Now you could say to me, well, Miss Bauer, isn't that the same as dividing by 81? And I would say yes. So if you would like to say divide by 81 instead of multiplied by 1/81, it's totally fine by me. Whatever works better in your brain. And last but not least, let's take a look at example D. B is directly proportional to the cube of A. So I'll just kind of write that out again for myself. And it's being multiplied by 27. So I've got C for my change is 27. And my exponent over here, my equation 3. C to the n is 27 to the 3rd, which happens to be 19,683. Direct means multiply. multiplied keeps it. So multiplied by 19,683. Okay, so that's kind of a lot of different examples in the fundamental theorem of variation. Sometimes this one is a little confusing, so go ahead, stop and think. What is something you do know now? Because I'm sure you know a few things. And what do you still have questions about? Write this down and come to class with those ready for tomorrow.